I'm currently working on writing a sensor for an IMU. An interesting problem came up, so I wanted to try to do a live coding session, implementing like offset and adjustment. Okay, so let's see here. Okay, so the sensor is an IMM 42652. This is a IMU sensor, inertial measurement unit. It's a sensor that measures the acceleration and angular velocity. Maybe angular momentum, I'm not sure. I haven't gotten to that part yet. So, the problem I have and need to solve, as soon as I have a diagram here, wait, give me 2 seconds. There we go. Okay, so this is the chip, the sensor. It has some axes. And we want to have a way to mount this sensor sideways and maybe upside down and 90 degrees, and like any way we really would figure is the best. But then our data will be wrong, of course. It won't show what we're expecting, since our rocket will be, we want our rocket standing upright to be level, right? So we want to basically pretend like this ship, however it's mounted in the rocket, will be level. So we need to implement a code that transfers or transforms this, or however we tilt it, into this, basically. So I've thought a tiny bit about it, but I don't know how to do it, so we'll see. Okay. Let's first start by drawing the sensor. And if I remember correctly, we had the z-axis up here. I have to go back and check, I think. I think this was the y and this was the x. We'll go back and check. Yes, with normal rotation, yeah. So this will be this way. This will be this way. That looks wrong. And this way. Okay. Okay. So, let's say we have this tilted. How would we transform it into this? I don't know yet. Right now we have it tilted a bit on the x-axis and z-axis, looks like. Okay, let's start off with a simpler solution. If we have an x going this way, how do we transform it to an x going this way? Still, it's a bit too difficult for me to see. Yeah, okay, I see it. Okay. Um, we want to find the x component and the y component of any vector, and then add them together. Yes. Yes. Okay. Still, this is difficult. Okay, let's try to simplify it even more. If we have two values, we want to find the transform between them. We'll take this x component plus this x component to get our x. And the same with the y components to get our y. That doesn't seem correct. I really don't know how to do this. Okay, I think I'm overthinking. Yeah. This is yeah, okay. Yeah, okay. Basically, for two coordinates, we get this. And then we just grab the components, right? For 3, I'm guessing it would be similar. Let's see here. Yes, yes. Okay. We'll have some value x, or some point x, y, z. And basically to get our true value, if we pretend like it's flat, we will, you see here, for 1, if we rotate this, meaning we have one angle here. Let's see here. This will be sine theta of our vector. I'll call this maybe r. Nope, this would be our y value. There we go. Okay. So our r value will change, of course, but our cosinus and sinus value will not. I guess for this set value we also need a different angle. So this would be let's see here. Do we want this angle maybe? I'm bad at drawing. I wonder what's like the normal. Let's see here. We'll have this angle. Such that should give us set. And then we have our sinus theta would give us y. Yes, I think this is correct. Okay, so we'll basically have an x component, y component, and a z component in our acceleration. We will have some theta and some phi. We're actually missing something, because this will only work for yeah, this will only care about the y spin and the x spin. But yeah, we actually need to care about the z rotation as well. Oh, I don't know how to do that then. So this is not fully the picture. Okay, we can assume we have an x, acceleration x, y, and z value. And theta, psi, and I guess what's normal omega? We call this omega. Psi theta. Okay, if we have some value, it's here. This may be misleading. I'll use a different color. We have some value. I'm very unsure to do this. Okay, I couldn't figure it out myself. I guess we'll Google a bit. Like we don't even quite want this because this is an actual rotation. We don't want that. We want the components in each. Yes, okay. So we want to figure out by having the rotations or the angles, what that would imply for our components in each direction. So I don't think this is correct either. Okay, let's pretend like it's flat. This here will read way less in our C, negative C, and instead way more in our, let's see here, C, Y, X, way less in C, now way more in negative Y. This is from the rotation around the x-axis. So as theta changes, we want to have... Okay, I guess we'll just walk through that for each axis then. That seemed logical to me. Okay. So we have x coming out. We have y. And we have z. So by knowing the x rotation theta, we should be able to get the correct x and y components by doing this. Okay, so I guess we want to set sine theta plus y sine theta will be equal to I guess we call this like true set. This seems wrong to me. Because right now I'm adding this plus this. Do this even seem correctly? As here. A back of the envelope solution. Like a gut check, I guess. Nope. So that's not how we do it. Yes, that's how you do it. My drawing is just bad. I'm conflicting the axis and with the measurements, right? So right here it will measure this much in the set component. If we tilt it, it would measure, the true value will be the same, and it will measure this in the set component and this in the y component. Yes, I think this is actually correct. Yeah. Okay. Okay. So this is set xy, rotating with, no, counterclockwise. We get this angle, positive theta, which would be here. This would be for set 90 minus theta. Right? Yeah. Nice. Nice. Okay. So for y coming out, psi, let's see here. Wait, how did I do it again? Fuck. X, Y. Fuck, I don't remember. Yes, X, Y set. Y coming out. That would mean we get positive x coming this way. Yeah. So, rotating y positively, we get that our true value will be the same actually. True value for x should this be. This is y. Okay. And for set, say that y and x set coming out, and this should, by the way, be phi. No, sorry. We called this omega. Omega might be a bad letter, but that's okay. Okay. I'm scared we're missing something. I don't think we are. But we'll see. I think we are. I think it's fine. Okay. This feels wrong, since yeah, I think this is wrong. Since now we're trying to find how set would change depending on how you rotate it. But that's sort of the key. It wouldn't change depending on how we rotate it. Neither would x nor y. Right? Since if we rotate it this way, set is always going to be true. So we're not... The rotation around x wouldn't change x. The rotation around y wouldn't change y. The rotation around z wouldn't change z. So here we're saying that our what did we say? X came out, we rotated it this way. Yes, okay, so this is still true. We're just not finding our true x, we're finding we are finding our For this one, we found our true set, which implies that our true y is set cosinus 90 minus theta plus y cosinus theta, I think. This seems way more correct. Yeah, I think this is correct. Okay. Yes. So this will give us one y. Yeah. One expected y measured in set and y. I'm guessing we also get one measurement of y in the set rotation as well. We'll see. Okay, let's go back. Okay. Set and y, we rotate around x. Rotating around x would give us this set value and what y value? Okay, our y value from our set component is yep, and our y value from our y component. Yes. Okay. I wonder if it's risky to just assume that this would hold for the rest as well. Expected value of yeah, I can't guarantee that is correct, and I sort of need to. Okay, let's try it out. Now we're rotating around y coming out. Does this make sense? X set y, rotating around, y would go down, yeah. That's the angle of y. So components. So our expected set value will be x sinus psi plus set sinus up, yeah. And our expected value, it's not expected value, but you get the point, of x will be no. Our expected C value will be this plus this. This implies that I was wrong earlier as well. So our set component no, I use this angle, which means I get this thing, which means this angle. Okay, yeah, okay, I was correct, never mind. Just have to make sure. Which means this should be honestly, we should maybe just use sinus here for all of them. Nah, that's probably bad. It's probably nice to have one rotational angle for each. Okay, so this is x cosinus psi plus set cosinus 90 degrees minus psi. Okay. Set coming out, rotating this way. We have y and x. Such that x cosinus omega plus Okay. There we go. There we go. That was a bit more challenging to find out. But now the deal would be that we get our Z component by summing these, our Y component by summing these, our X component by summing these. We can like check this to make sure it's correct. Let's say we have the device sitting on the floor like this, such that everything is in the Z direction. That would imply no X rotation and no Y rotation. So if psi is 0, this is 0, this is 0, this is 1, no, this is 0. Oh fuck, never mind. It's here. This is 0, this is 1, so we get set. And this is 0, this is 1. So it's not summing them. I maybe just figured out twice as many identities as I needed. Let's see here. Do all the rest go to 0 then? So if this is 0, this is 0. We expect that X and Y should be 0. So if this is 0, this is cosine of 90, which is 0. If this is 0, we get Y at 0 because it's to that 0. If omega is 0, this is 0. And then this would be 0. Omega 0. This is 90, so this is 0. And if omega is 0, X is also should be 0. If, let's see here, if theta is 0, this is Y, which should be 0. This is 0. This one is 0. Yes, I couldn't find any mistakes at least. So I guess we just have multiple ways of finding it. This feels kind of wrong though. Because now for iteration in theta, I think I have to think more about this. Do we sum these ones? Or is this? Is there more to the story? Yeah, no, we're yeah. We're summing them, yeah. Okay. I think we're good. Okay, time for programming. Okay. So we need acceleration data. I guess we do this. And I tried to make this earlier. So I guess we also should do this. Okay, so we take in an orientation. Which would mean we need to calculate does this make sense? We have a rotation. We want to find. I'll open it again. We have a rotation. We want to find this, 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 and this. For these ones, we can actually call this I guess it's better to keep it like this, actually. Yeah, the calculation has to be done either way. Yeah, okay. So, for rotating around x, we need sine. Also, by the way, I want to pre-compute these ones. We could have one that inputs the sensor values and then converts each of them. But we know the angle, and the angle is stuck. So we only need to compute the rotation factors once. Okay, so we want a sine and cosine rotation. Mm. I don't know what else to call it. Float O M O sine rot. There has to be a better way of doing this. I can't think of it right now, so we will just finish it like this. Then rather refactor after. Okay. So we pass in an orientation. And we want to compute these values. I guess you just get these ones, okay. Double float long, I guess. M sin rot x. And okay, so our rotation will not be this then. Our rotation will be... I guess float is a bad way of representing it. I guess we call this U and 8. Oh. And this will be in the grease. Counterclockwise, see data sheet. Yeah. Then we pass in this is rotation around the x-axis. Then we have rotation around. Let's do this one first. So this will be 90 minus x. I feel like this is kind of risky way of doing it. But let's see. Cosinus will be sine f. Sorry. I'm looking at the formulas we made earlier. Rotation, and then O cosinus rot will be 90 minus x. Yeah. And also this is not... Let's see, I can automate this. Sine sine, sine, sine. It's here. This here will be nothing special for now. Okay, and also this is orientation, so this will be m orientation dot x. That looks like it's switched here. Cos, cosine, sine, sine, cos, sine, cos. We'll just go like this quickly. So the inverse one will be 90 minus. Boom. Boom, boom. Okay. We maybe want to do this in this file instead. I don't know how to do this. I don't know how to initialize an empty class. How do you... what am I doing wrong? Maybe I don't need this. I want to do this. Okay. Guess I'll do this some other time. Okay. Nice. Now we should have these angles. Convert. Let's call this acceleration. I don't know what's happening. Maybe it's just the reload. I wonder if this is the same problem as earlier. I guess maybe there's some type here in it. Oh, yeah, okay. And this should be IMU data. I guess that was the problem earlier as well. We can just fix that then. So we'll see. Take this. Guess we don't need this then. Should this be here? Do you have to do like type a name? I guess we're passing in IMU data here as well. Okay. Nice. Nice, nice. Orientation, we have orientation. Pass some IMU data. Calculate our offsets to begin with. Then we take in acceleration data. And return. Yes, here. We take the data for x will be data x, acceleration x, times our m equals rotation y, m equals rotation y, plus set data acceleration set times m o equals rotation x plus data acceleration x times rotation around set m cos rot set plus data acceleration y times m cos o root. Is that not? Cos m o cos root set. Okay. We should maybe not try to speed through this. I feel like this is an easy place to make big bugs. You know what, let's rewrite the whole thing so we're sure we're correct. Okay, so for y, we get data acceleration set times m o cos rot x plus data acceleration y times m cos rot x plus data x times m sine rot z plus data y times m o root sine rot set. Then for set we have data set times m o sine rot x like all of these ones should be single. No, have two of them. Right? Fuck, I think I made a mistake. Okay, we'll read through it after. Data acceleration set times sine rot opposite 1, 2, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Yeah, so I guess all of them are single. And we just made a mistake on this one. Okay, so for x, this is x1, should have set times cosinus O rotation around y. That's a mistake. For y1, we have set opposite rotation around x. Yeah, I think that's correct. Okay. I think we might be done. It'll be interesting to see if this is like flawless or if there's a hidden mistake somewhere. That's pretty cool. Pretty cool. I don't have a way of testing it right now, so we'll see in about 2 months' time if this is correct or not. But yeah, pretty cool, pretty cool. So now, ultimately, you would have this IMU, right? I don't know if you have an init function yet. So then we can have that A reads data. I don't remember what we call it. To have some data, right? This is probably IMU data. Then we can do acceleration data. Acceleration should be data acceleration data. Then we do IMU convert acceleration data. Something like this. I wonder if this is how it works, or if you call it on the object. If you do like this convert, I'm not sure. That's different story. That's pretty cool. Hopefully that will work. We'll see. But yeah, I think it's pretty awesome. We'll see. I'm hopeful. Every step made sense to me, and I don't know what step might be wrong. Also, this is very quick. We compute the angle conversions once on the initialization. With high precision. There's one possible bug if you input one rotation that's which is not no. If you input correct rotations, this should be fine. Yeah, I think it's fine. We'll see here. In degrees counterclockwise. I guess we're gonna have like range will be 0 to I'm scared to type 360, so I'm gonna type 359. I'm not sure if 360 works. But 0 should work. Yeah, okay. Yeah, anyways, I think I'm done. Cool project. Hopefully it works correctly. We'll see. Right. See you.